Having seen the intuition behind using a fixed size sliding window to solve the sub-array sum problem, let's now convert that intuition, that idea into code. Now, this is something that has to be always done very, very carefully because while discussing the idea, while defining the intuition, we can be a little bit sloppy, but when it comes to writing code, we have to be very, very careful. We have to be precise, and hence every condition that we are putting in has to be thought out carefully and carefully analyze. So that's what we're going to do. We're going to go through very, very slowly, highlighting every aspect of this code. We start with defining a function, call it max subarray sum efficient. Again, the arguments are the same. Well, L and K. L is the list, K is the size of the window. I start with my assignments of variables. Most importantly, I assign 2 pointers, left and right, to 0 and K respectively. Now this is very, very interesting. Recall the first window goes from 0 to k minus 1, which means that subsequently for any window, my left pointer is in fact pointing to the item that is leaving. My right pointer is pointing to the item that is entering. We'll make use of this fact a little bit later, but I assign my current sum. I compute the sum for the very first window. Remember, this goes from 0 to k minus 1. So kk goes from range in range k. I compute my current sum. I assign my maximum sum to the current sum. Now I run a while loop. Now this is while right less than n. Now think about it. This is actually very interesting. Once the initial window has been computed, the right pointer is pointing to the item that is entering the window. Now the last item that can enter the window, the last index is clearly n minus 1, which means that I must run this while loop while right is less than n. The largest value possible is n minus 1 because I'm going to increment right by 1. We'll talk about this. And hence at n minus 1 is the last, and hence I say, well, while right less than n. So this less than is important, this n is important. Having done this, remember I am now looking at windows from where I can find the sum by taking the previous sum, which is the current sum in this case, adding the item that was entering and removing the item that was leaving. So in this case, look at the very first window, right is set to k, left is set to 0 because for the very first window inside the while loop, remember that is actually the second subarray. The first window went from 0 to k minus 1, which means item k is now getting added. Item 0 is now leaving. So that's why I update my sum this way. Think about it. Very, very interesting. I update the maximum sum if that's required. Most importantly, I move both the pointers. Notice I move right by 1. I move left by 1. Now, I like this about the while loop implementation because the movement of pointers is explicit. It's very clear that the separation between these two is not changing, which is why we call this a fixed size sliding window. And once the while loop exits, I return the sum max and the index max. Before writing any code, let's just analyze this a little bit more carefully. Remember the 2 pointers here, left points to the item that is leaving the window, and hence inside the while loop we always return left plus 1 because the actual window starts here. So we'll talk about this in a moment. Right on the other hand points to the item that is entering the window, and hence the max value of right is n minus 1. We spoke about this. Thus the while loop goes from right while right is less than n, and in fact that's why we are doing plus L right minus L left. Now some specific cases which are interesting here. Let's say my sum max happened to be the very first window. I mean, it's possible. In this case, if that happens, basically, yes, I computed my sum max over here. Remember my index max here was set to 0. If this was a situation, I'm never going to be entering this if condition at all because current sum will happen to be the, basically the sum max is set to current sum. If anything else is not more than sum max, I don't enter here, which means that I will not update my IDX max. IDX max will return as 0 as we had wanted. However, the moment I am entering the while loop, remember my left inside the while loop is pointing to the item that is leaving, which means that my window actually starts from left plus 1, and hence I will return left plus 1. You notice I'm setting index max to left plus 1 because like I said, left is where the item, I've left is the item that is leaving. The window itself starts from left plus 1. And that's what I'm trying to say here, that look, when I, for example, compute for this guy, left is 0, so I'll return left plus 1. When I compute for this guy, left is 1, I'll return 2 because 0, 1, 2, that is where the window is starting. Like I said, this detailed analysis is important. Otherwise, mistakes creep in the code and it gets very, very difficult. Let's now write this code. So I write a new function called, let's say, max sub array sum. Let's say efficient. So maybe efficient. And again, the two arguments are L and K. So the basic definition doesn't change. I just use some variables here to sort of initialize. Sum max is 0, index max, IDX max is also 0. So I set both of these to 0. I get the length of the list to be called as n inside my code. I set my two pointers left, right, remember, to 0 and k. K is the size of the window. So first I compute the very first window. So I just do for kk in range k. Well, cur sum, which is the current sum. So I need to define this variable. Cur sum is plus equal to L kk. Now for this statement to work correctly, I must also initialize my cur sum. So I do that, say cur sum is 0. Now, having done this, remember this is the first window, which we must compute explicitly, which we are doing here. I just define my sum max to be cur sum, so that my sum max gets updated to the very first window sum. Now comes the sliding window action, and I am doing that with the while loop. So I say while right is less than n. We spoke about this in detail. Cur sum, which is going to contain the running sum of the different windows. Well, it's going to be cur sum, so the previous window sum plus the item that is entering minus the item that is leaving. Having done this, I ask myself if my cur sum is greater than sum max. So indeed, if I found a window which is, which has a higher sum, I just go and say, well, sum max and IDX max, I'm going to assign these to cur sum and left plus 1. Remember, because the window itself started at left plus 1, I am removing left here because left right now is pointing to the item that is actually leaving. Very, very, very important point. Think through it. Happy to discuss. But having done this, my two pointers must move. So I just say right is plus equal to 1 and left is plus equals to 1. Now, this is what I like about the while loop implementation. Explicit how the pointers are moving, and you can clearly see that they're sliding across the list. And having done this, I just go and say, well, return, say the sum max and IDX max. So if you see the interface, I mean, from the, so let me see if I got the indentations right. I think I got this wrong. So it's got to be inside here, right? Now I'm just going to take this piece of the code as it is, and we should, I'm just going to copy this over here so that we can run this on our new function. Because the interface I have intentionally kept the same. So I'm just going to say, well, please tell me the max subarray sum, but this time around I'm going to do efficient over here. We'll talk about why it has become efficient a bit later. But when I run this, notice indeed I get the same answer. The max sum is 51 at index 2. Let's make this, let's say, very, very large. Let's say 112. So max sum is going to be at index 1. Okay, so because this was 1, so index 1, that's fine. But if I made this also 100, then clearly max sum is at 0, which is 252. So this is basically working. Let's say I added maybe large number over here. So I'm going to skew the sum to the right side, and indeed at index 6. So you can clearly see this is working. We'll look at why this has become more efficient a bit later, but look through this code carefully. Everything here has a meaning. Everything here has a reason to be put in. Very happy to discuss. I hope you found this interesting. Do look at our website www.ybyte.in, because we learn programming in a fun but rigorous way, looking at things carefully, understanding every aspect of code in a nice manner. Take care. Thank you so much. Bye bye.